A few weeks ago I released a video on the channel about electric vehicle gearboxes, and I looked at what's inside an EV gearbox, and in this case it was a gearbox from a Hyundai Ioniq. But I made a couple of mistakes in that video, and primarily I got the mounting orientation of this gearbox wrong. So in this video I'm going to make it a part 2. I'm going to correct those mistakes, and I've got some additional information about the wear inside an electric vehicle gearbox. So if you haven't seen the original video, which I'm now going to rename to part 1, I'll put a link at the top of the screen and in the video description below, so maybe you want to watch that before watching this video part 2. So thank you Board Kiwi for pointing out my mistake with the mounting orientation. So I thought the gearbox mounted like that, so the electric motor was driving the top of the gearbox, it was mounted vertically, and then you've got your half shafts here going out to the front wheels. But I was wrong, it's actually mounted like that, so the electric motor is at the front and then it is mounted horizontally. So with the gearbox mounted horizontally like that, we've got the park actuator at the top of the gearbox. This is controlling the park pool inside. And then if I look at a Hyundai Ioniq 38 kilowatt hour here, the gearbox is down there, and they are difficult to see, but if you can see there, that is that park actuator. It's probably a bit difficult to see because the sun's bright and there's strong shadows, but if you can see that plastic top of the park actuator there, that's sitting on the top of the gearbox, and the gearbox is mounted that way, and then obviously you've got your drive shafts to the front wheels. And the other thing I pointed out in the video was about a water pump mounting, and down there is that water pump, and that's the only difference between a 28 kilowatt hour Ioniq gearbox and a 38 kilowatt hour Ioniq gearbox, is you've got the mounting holes for that water pump, and that water pump is then pumping this coolant around the battery pack. But on the 28 kilowatt hour models you don't have that additional circuit because it's got an air cooled pack, so that's why you can't fit a 28 kilowatt hour gearbox on a 38 kilowatt hour model, but you can do it the other way around. You can fit a newer gearbox on the older models because they're identical internally, and the mounting points and everything is just that the newer gearbox have those additional mounting points there for that water pump. But if we stand back and look at the drivetrain here, we've got the electric motor here mounted that way with the drive shaft coming out the end, and then you've got your reduction gearbox mounted that way, so that drive shaft is then spinning your reduction gearbox, and then you've got your drive shafts to the front wheels. So that's how it's mounted. So if we come back to the gearbox here, because I got the orientation wrong, I also got the oil drain plugs and fill plugs wrong. So when the gearbox is mounted like this, this is the drain plug for the oil and this is the fill plug for the oil. So the level of the oil sits all the way along the bottom there. And then if I just separate the two halves, so as we can see on this half, this is our fill plug, this is the drain plug. So the oil level sits just below the drive shafts there. So it's at about that mounting bolt there, which is that one there. So this is the oil level about here. So as you can see, majority of this is running outside of the oil, but of course it's all getting flicked up around the gearbox, so all of this is lubricated properly. So another thing I got wrong, obviously the orientation. So this magnet is sitting in oil all the time at the bottom of the gearbox. However, any debris on that magnet isn't getting flushed out when you drain the oil, and you're draining it from this point here. It's always going to stay on the magnet. So let's have a look at this magnet in more detail. This has not been cleaned at all. So this is what the magnet looks like on a gearbox that has done 100,000 miles. So let's just have a look at what debris is on here. Just soak up the oil there. Not sure whether that's focusing, but I don't think that's too bad. So what I've also been asked to look at is the wear of the magnet and its little enclosure here, because with this magnet sitting at the bottom of the gearbox, this is rattling around inside that little enclosure, and it's also rotating with the oil being flicked around and spun around by these turning. And what someone else has found when they've analysed the oil from a Hyundai Kona EV gearbox is that they found both iron particles and aluminium particles. But the magnet looks absolutely fine and no wear. The surfaces are still incredibly smooth, so that all looks good. And then the sides of this little slot that it sits in, you know, if that is turning around, theoretically it's going to be wearing on the inside edges. And as I said, this gearbox has done just over 100,000 miles. If there is any wear, it's not noticeable to the human eye. So in this case, it all looks good. But this design of having a magnet permanently sitting at the bottom of the gearbox there collecting the debris, rather than having a magnet on the end of the drain plug where it's going to get cleaned every time you change your oil, it's just strange to me. But then I suppose these gearboxes are designed to be sealed for life. An oil change in an EV gearbox isn't part of a scheduled service by any manufacturer I know of, apart from the original Mitsubishi i-MiEV. So maybe that's why they've designed it, that it's sealed for life, and this is just going to catch any debris over the lifetime of the car and it's permanently going to sit there. But it does seem to make more sense to have a magnet in your drain plug here, and then at least if you do oil changes, you're going to clear out any of that rubbish. So now let's look at the park pull again. And in your EV, when you select park, what that's doing is activating this park pull, and this is a lever which then locks in here into this gear here, and that locks your transmission. So on the other side of this is the electric motor driving this transmission, and that lever goes clunk and locks into that gear set there to park the transmission. And in the original video I wasn't sure how this worked, because I'd made a fundamental mistake thinking this wasn't in the park position, this was off. But of course it's the opposite, it's actually parked at the moment, and it all makes a lot more sense, because this little sort of mushroom top on that threaded bar there is of course sticking up, and that's pushing this lever into the park position. So here's the activator, and this is just basically turning that shaft there, which in turn is pushing this cap up and down. So because it's up at the moment, this is parked, and when that drops down, this lever to move that extra centimetre across there, which is going to drop that down and therefore disengage it. I've since made another video about parking electric vehicles and correctly stopping them, because a lot of people get it wrong and they park the vehicle just on this park pull without using the handbrake, and if you put too much pressure or you put the weight of the vehicle on this park pull, it can cause quite significant damage, particularly if you're parked on a slope. So that will be on the channel soon. I'll put a link to it at the top of the screen and in the video description below, but at the time of releasing this video it won't be live yet, so that will be another couple of weeks time. And as I said in the other video, this park pull setup is the most complicated part of the gearbox. It's quite surprising how much is required just to make a lever do that. Obviously you've got your actuator here, electrical connections, which is then turning that spindle at the bottom, which is then pushing this up and down, but there's still quite a lot in there. It's quite surprising how much is required. So the most complicated part compared to the rest is incredibly simple. So now let's talk about wear and tear, because one thing I mentioned in the other video is while these gearboxes are incredibly reliable, because there's just not much going on inside here, There are a few EVs which are known to have issues with the gearbox, and primarily that's the Nissan Leaf and the Nissan ENV200. And when I've done gear oil changes on those vehicles, I have noticed metal particles in the gear oil. But since someone has posted that the issue is the differential here, and it's the gears here in the differential which are the weak point on the Nissan vehicles, and it's just because they can't handle the torque. So if you want to look after your reduction gearbox in your EV, you don't want to be racing away from the lights. You want to increase that power gently and just put as less stress as you can on your differential. Because what's happened, someone's posted recently on a Facebook group, is they've taken a Nissan gearbox apart. Well, they've taken many Nissan gearboxes apart, and they found that it's always this here that is missing teeth. And if you've got a vehicle that makes a clunk when you're turning the wheels, that's a symptom of this problem. But as you can see here, there's absolutely no noticeable wear on any of those in this Hyundai gearbox. So finally, the last thing is this plastic item here. I didn't understand what this plastic ring was for and what it was doing. As I said, I've got no experience of gearboxes. This is the first time I've opened a gearbox up, and many people have said this is part of a speedo in other gearboxes, but it doesn't have that purpose in this gearbox. And others have said that the Kona gearbox doesn't have this, but it seems now this obviously is a differential set which is used in other applications, used in other gearboxes by the same manufacturer. I assume Hyundai actually make this, so this differential set is used in other Hyundai and Kia cars, and they've just kept this the same in the Ioniq here. But in this vehicle, this plastic part has no use at all. If anything, it's probably more just a packer getting this bearing in the right place and keeping all the package dimensions the same. So in this case, this has no purpose at all. But obviously this differential set here is used in other gearboxes. So that's it for this one. If you found it useful, as always, please do click the thumbs up button. That really does help. Also subscribe to the channel, and have a look at the playlist as well, where you can see other videos on electric vehicles.